Good morning, everyone. So we've got a bit of an adjustment. There were 4, and now there are 2. So we came here to talk a little bit about, have a panel discussion just about kind of breaking down barriers to HPC, and the challenges that we face in the open source systems, and in the open source world, and Ubuntu in general. And kind of that's what we're here to kind of have a talk about. We've got a few different questions as kind of like preceding and thinking about kind of what we want to talk about and things of that nature, just to kind of start. We don't have a moderator for this. However, that being said, we do feel that this would be wonderful if it was a collaborative discussion where we can get questions from the audience to help figure out what you guys think about the challenges that might be facing HPC and open source. We'll do some introductions. I'll turn it over to someone far more intelligent than me. So, Jaime, would you like to introduce yourself?
Yes, thank you, Willie. It was really kind of you. Hello, everyone. So my name is Jaime. I'm an HPC engineer working at Omnivector. We started collaborating with Canonical a few months ago, right? Developing the Slurm charms and starting an HPC community for Ubuntu. So the idea for this panel is so we can start discussing how we can improve Ubuntu for HPC environments. So we would like to expand Ubuntu adoptions on HPC environments. We started some initiatives in that direction, and we would like to bring that discussions for you so we can bring questions, bring suggestions. We have an open community for that, and you are very welcome to contribute with this initiative.
Okay, thanks, Jaime. So my name is Billy Olsen. I am engineering director at Canonical. I am fairly new to the HPC world, actually. So in January, I got the opportunity to kind of help work on the HPC at Ubuntu projects. And I jumped at it because it was really exciting, but it's also, I had no idea what HPC was, which is one of the greatest ways of actually learning something is to just jump in and do it, right? And so I kind of have a unique perspective from someone who has not understood HPC and HPC computing and going after these, after scientific and supercomputing type activities on large clusters, and except for the last 9 months or so. And so, I come at it with a rather new and fresh perspective from and one of the things that I think of is just kind of like the overall accessibility of what HPC is to a lot of different folks. And I think that's some of the interesting challenges because we talk about HPC and, it's kind of either you know what it is or you think you might have a vague idea more than anything else. And I think that's kind of an interesting aspect of the overall piece. So we started with a few different questions that we were thinking that we would kind of start moderating on and kind of just kind of spitballing on to kind of start. But we do want this to be an interactive session, so we'll start with a couple different questions. But please feel free to raise your hands and ask questions of us, and we will give you our thoughts, and we can go from there. So Jaime, one of the things I think has been interesting and is kind of, as we look at the landscape of high performance computing, open source is a big part of it. We've seen this migration from early days of Cray systems and things of that nature, where they were really pushing forward what high performance computing was and what you could do. And then it moved into a more disaggregated type architecture where you ended up with clusters and clusters and clusters of compute, and open source kind of came into an interesting time there. So one of the things I love is just how popular open source and Linux is in the HPC industry. Even HP bought Cray, and Cray still has supercomputing machines today, and they have Cray OS, and that's Linux based these days, where it was not before. So I think it's quite interesting to see the prevalence there. But there's also this kind of tension between open source and the fact that a lot of the advancements of technology, advanced software, things of that nature, it is kind of a proprietary nature due to the way that certain parts of the ecosystem has evolved. So I was just kind of curious if you could share your thoughts on open source and proprietary natures of hardware accelerators, software packages, and kind of what you see the challenges exist around just general adoption of HPC in a more open ecosystem when you have kind of those two different pieces of tension at play.
Yes, I've been using HPC for a while now. So I'm from academia. I started using HPC in academia. So back then, I started from open source since the beginning. So I didn't have much experience using proprietary software to run HPC. And now in the industry, we have clients with those kinds of software, for example. But basically, for the let's say the basic infrastructure, we are using open source for some time now. We don't need to, of course, we just need to pay for the hardware, but the software is open, is over there. But the applications, we are still not. We still have a lot of applications that requires licenses, and I don't think that will change because it's the market, the way it works. They are developed for that. But somehow, I think we can start stimulating, even for the applications that runs on HPC, we can start stimulating the use of open sources. For example, I'm also a PhD student. So in my research, I use a lot of open source software. So I think we might change that, but especially in academia. But for industry applications, I still see this challenge to change this scenario. So we still have the basic operating system open source, but not the whole environment. So Billy, what do you think? How can we change this scenario? I think it's a little bit hard.
Yeah, I think it's hard. I think it extends, from my perspective, if I look at like the ecosystem, you have applications and ISVs that are out there that are providing software that they've run for years and they provided support for years. I think that this is kind of where it runs into industry and academia, actually, as far as like license counting. Certain research grants are really associated with specific types of research and software that actually meets that particular need. One of the things I think that makes it really challenging is that enterprise Linux has been kind of like really prevalent in the world of HPC in general. Like if we look at the numbers and the breakdowns of what operating systems different HPC clusters are using, there's a very large number and percentage of them, about 67% of those are running enterprise Linux. And I think that tends to lean in towards the choices that ISV companies are going to be making and the different software packages that they're going to be making and delivering. They're going to be targeting kind of the largest base. Now there's been recent moves in the enterprise Linux space that may end up helping the Ubuntu community and things of that nature. I think that it's gonna come from people making deliberate choices and partnerships between organizations and open source with these ISVs as they start looking for different options, such that they're not necessarily, they're going to be pressured by their clients to look towards different types of options in certain cases. But I also don't think it just stops there. Like if you take a really good hard look at just like what the hardware ecosystem looks like, you want to get, in an HPC cluster, you have a lot of high-end hardware. I mean, extremely high-end hardware. And the open source community, what we do on open source isn't necessarily fast, right? So if you want to put out a very, a brand new network driver or something like that has high bandwidth capabilities, but fundamentally alter some different nuanced pieces of the kernel. You can provide your own patches to give those to your clients, to your users that are purchasing your hardware, but to actually work with the open source community to get the fundamental changes that are actually necessary to make, because it's very likely that when you've proposed patches, you've thought about it very specifically as to how you, what's important and how you think about the particular networking space, if we're looking at networking as an example. But there's other players within the ecosystem, within the open source kernel, and how they actually respond to that. It is a community effort. The community makes decisions, and architectural decisions are not owned by a single vendor or a single person. They're often collaborative, and these take time, right? And commercial interests don't always follow at the exact same pace of play as open interest, which I think is an interesting challenge in open source in general. And then if you're looking at it like from like a distribution perspective, from like say Ubuntu, it also gets kind of complicated, because you have to weigh and balance out the different options of how, if we want to support something as a distribution, say, from Ubuntu, we make certain guarantees and certain promises about security patches and updates to software, and that software will continue to work and continue to run. And that becomes increasingly difficult if you take a look at different types of adjustments and tweaks to the overall ecosystem. It's really important to be able to try and support those vendors, because that will necessarily mean higher adoption. However, there is that tension of, if you take that higher adoption, you have to weigh it carefully with what the direction of the upstream and the open source community wants to do. And so it does get a bit challenging. But I also think that, it's really encouraging the vendors, the suppliers, to more actively participate in open source. And that's not to say that they aren't. I know several vendors out there are working in open source, are working with the communities. But again, it gets back to the tension of doing something from a commercial aspect of being able to deliver hardware or new innovative solutions can be, at odds with the pace of play of an open ecosystem, where in an open source community, where you're actually deliberating across a variety of different concerns at that point in time. So
Yeah, in this discussion, I'd like to add something. What is missing in Ubuntu so those vendors can start supporting Ubuntu also? I mean, we have some cases. We deploy a few the clusters at Scania, and Scania uses a lot of different softwares for modeling and simulations, and all of those, the most of those softwares actually they required licenses, expensive licenses. But we've been trying to deploy the clusters using Ubuntu for some time now, but it's still not possible because those vendors, a few of them actually, does not support Ubuntu. So we still need to deploy on enterprise Linux like CentOS, Rocky, Alma Linux, but we cannot use Ubuntu. And we've been trying hard to use Ubuntu, but we have this big blocker. So what's missing? What do you think, Billy, is missing? What could we do to maybe, I don't know, should we go to the vendors and say, hey, we are starting to use Ubuntu for HPC. Please support us so we can deploy it in our clusters. What should we do? What do you think?
Put me on the spot for that one. Yeah. So I think it's kind of interesting. So HPC is a large field, and oftentimes I think that we take a look at it and we say, HPC, how are we going to solve HPC? But if we actually look at it, Ubuntu is very successful in certain spaces within HPC and less successful in other spaces within HPC. We mentioned the ISV story and the challenges there. I think we need to make sure that we celebrate the places that we do have our successes. So as an example, in the AI ML space subset of HPC, Ubuntu is actually quite prevalent in that particular space. And I think that that's something that we should embrace. There's a lot of openness in that space. There's a lot of non-openness, right? The proprietary solutions and things of that nature. But I think that as that is a newer and relatively younger field in many ways, I think that that's kind of helped that Ubuntu is there providing the latest, greatest tools and the rapid delivery of software and stability of software that Ubuntu can provide is helpful in that space. I think where we run into challenges are some of the places where there's been an established industry for a really long time. So things like computational fluid dynamics and things of that, other types of software in that particular space. This software has been around since the 70s, the 80s. And Ubuntu hasn't. And so choices have been made and around operating systems. And in many ways, with an established industry like that, it is more difficult to move the ship. It's more of a ship than a boat at that particular aspect. So I think that's something that we have to actually look at and understand where that particular subset of the industry is actually at, and what do we need to do, and how you can lead a horse to water, but you can't make it drink in many cases. So you can kind of show where we have advantages and where we haven't, but we also have to sit back and listen to what their challenges are, what the concerns are, and see what we can address in those particular spaces. I think it's really interesting. The world of containers in HPC, it looks far different than the world of containers in other industries. You're basically giving shared access to a bunch of users you don't trust. That's always an interesting aspect of how do you actually make that work. And so there's a variety of security concerns. And I think that, when you look at the researchers and the different types of users that are on these types of systems, their primary focus is not to be software engineers. There's not to be, you're using the latest, greatest OCI technologies. Oh, I'm jumping to Kubernetes and things of that nature. The users of the supercomputers and who we're targeting are more like research scientists and people trying to progress certain fields of study. They're studying battery chemistry and running different simulations and calculations on what happens when we make these certain types of chemical changes to see if we can increase the density of energy storage. I think that's incredibly interesting. It's far above my level of knowledge. I think it's really interesting to do that, but I wouldn't walk into their field and say, oh, this is exactly how you should do this, right? I'm going to walk in and say like, yeah, you should actually use this chemical instead and put it in this particular arrangement. I have no idea what I'm talking about when it comes to that. And in many ways, I would use the tools that they would provide me. And I think that that's much kind of where we're at when it comes to who our users are of the HPC story, is the users that are using the clusters. They're not software engineers. They're not IT administrators. They have other jobs. They have other expertise, and they're focusing on it from that perspective. And so they're going to use the best tools that are available to them in many ways. We have the containers, and you can containerize applications. You can put it in there, but it's yet another hurdle. All they want to do is their research. We've added yet another layer of complexity for them to be able to do their research at whose expense? Their expense for our benefit. And I think that that's some of the challenges that we do face in the HPC industry is if we want to progress Ubuntu moving forward, we do have to come up with creative solutions which address both the ISV space, trying to partner with them, but that's also going to take them time to actually adopt it. And we can tell the container story. I think that's a good story to help us bridge the gap. But at the end of the day, we're kind of pushing the trouble onto the end user, and that's not really, they're not experts at that. So that's kind of my thoughts on that particular space. So I was curious from your perspective, when you take a look at like the different ecosystem out there, what do you think the users of the HPC solutions that you help manage and help run, what do you see their challenges as they try and use the ecosystem of HPC software?
for the users, I mean, on HPC environments, the end user is an engineer. They just want to run their simulations as faster as possible, and they don't want to care about configurations, about complex work ways to run their applications. So I think that they don't care about the underlying system. If we are using Ubuntu, if we are using Enterprise Linux, Rock Linux, it doesn't matter to them, just as long as they can run their job. So in that direction, I think we just need to provide ways to make their lives easier to run their jobs. I mean, we just need to provide everything they need. In that direction, I think containers is a good thing, because with containers, we can just pack everything we need to run an application. And a user do not want to be loading a lot of things to run their application. They just want everything in a single place, and just run as minimal as possible to run their applications. So at Scania, for example, we usually have some problems to propose new ways of working, because they are too used to their way of working, and it works good. They don't want to change anything. So how can we change something that is working good for them? That's a challenge. And you face those challenges every day. And to start using Ubuntu, so we should start using Ubuntu, making those changes, changing from Enterprise Linux to Ubuntu in a way that you will not notice that. Because if something change in the way they use it, and they think it's complex, they are going to drop this idea. So in the user perspective, I'd say, I just want to run my cluster. I don't care how it is deployed, what's installed, just as long as I can run my simulations.
Okay. So I think one of the other things that I think is a good thing when I think about HPC and I think about myself and my own journey, you know, I looked back and 9 months ago, HPC was just kind of 3 letters on a screen and kind of like described out there. And I think that in many ways, a lot of people don't really know what HPC computing is. I mean, does everyone here feel that they have a good understanding of what high performance computing actually is? Yes? How many people have worked in a research center and used a high performance computer? 1, 2, 3, 4, 5. Okay, about 5, 6 of you. And for the rest of you that are in the room, do you feel like you have a handle of how you would run an HPC job, what types of jobs you would use HPC for, or anything of that nature? No one. Okay.
I mean, I'd ask that when you say HPC,
yep,
are you defining that by like the power of an individual node, or how it's scheduled, or tools that are being used? Like what do you think create the boundaries of what HPC is, particularly as you've got like these massive, you know, GPU accelerated Kubernetes clusters on the cloud and stuff that are not HPC but look a little the same?
Yeah, I think that's an interesting question, is like, where is the boundary, and kind of what is HPC to a degree, essentially, is what you're asking, right? In my mind, HPC is about processing either very complex algorithms that requires necessarily so distributed systems due to the complexity of the types of problems that you're trying to perform the calculations on. Or it also considers large data sets that you would be doing analysis on and things of that nature. So I tend to think of high performance computing. The big things that come to my mind are it's going to be necessarily distributed across multiple nodes, and it's going to be necessarily complex with the types of algorithms and computational workflows that you're putting at it. You might have small samples on your local machine, but you really need a large number of machines to result in more interesting outputs and problem spaces that you're trying to solve. Over here, there you go.
Yeah, maybe I can shift in a little bit in the
Okay.
conversation. What is the difference between? Thank you. Now, maybe I can chip in a little bit on the difference between high-performance computing versus possibly big data processing, because to me they're not exactly the same thing. And I can bring this example because it comes with my experience a little bit. I did my PhD in fluid dynamics, computational fluid dynamics. So it was around about running extremely big numerical simulations, and those simulations, they were running, let's say, on 10,000, 20,000 cores. So a lot of cores, but the memory footprint was extremely small. It was like maybe 50 gigabytes. So it was not that big. But in order to actually advance the computation, so to make prediction, to simulate turbulent flows, you really need this flow field to produce a lot of computation, really like maybe for months. But the memory footprint is fairly small, actually. And that's HPC. When it comes to big data processing, on the other hand, which is what most companies they are concerned about, is the fact that they have a lot of data. So the memory footprint, if you think about training a model on all your customers, maybe you're a big bank, you've got million of customers. Every customer has got a lot of features, so you have a lot of data, and the computation is less important. So I would say the main difference, what for me tells a little bit apart, big data processing versus HPC, is really the computational cost versus the memory footprint. And so that's a little bit like where I draw the line. I mean, nowadays, things get a little bit blurred because, of course, also training like a neural net, it means a lot of computational cost as well. Like maybe I would say 3-4 years ago, it was less so, in the sense that really big data processing was like extremely large scale data, whereas HPC was even like a small footprint, but a lot of computational cost. That's so that's a little bit where I sit.
In your case, did you have a lot of communication between the nodes?
Yes.
And I think that's also distinguished. Like if you do analysis, you're the computationally bound and not as you put it, their memory, but also you're independent.
Well, I think to some extent, you don't have as much, I would say once again, communication because once again, at the end of the day, your memory footprint is not that big. But still, you've got different codes and different, version. The code I was working on needed, all the nodes to communicate with most of the nodes most of the time. But you also have like codes that are a little bit more efficient on that respect. That you just communicate with neighboring code. So I think that depends a little bit on the use case. But nevertheless, if the memory footprint is low, the communication is not that big anyway.
It could be a limiting factor, like for weather
forecasts,
it is. Would be a prime example.
No, it is.
Yeah.
You see that, your performances, as you really scale to, 10,000, 20,000 cores, you try to actually get this linear scaling, but, the communication is always there, damn it.
Yep. Yep.
Thank you for those discussions. I think HPC must be a combination of two things. The infrastructure you have and the workloads you have to run. You need to run. Because I can run just a hello world simple script on an HPC cluster. Yeah, I can do it, but it's not suitable. I can just do it. I should do it on my laptop. And I cannot run, for example, the deep learn training for a big data set on my laptop. I think it will explode. So we must have the two things. Usually when you say about HPC, we are talking about clusters. So basically we have a set of nodes, 100 millions or thousands of nodes, depends on the size of your cluster. And of course, communication is the key, because we must have a workload that will be split into different processes, and those processes are spread across those nodes, and they must communicate with each other. And that's how we scale our application. We add more nodes, and we're gonna have more computational power, and then we can start using HPC, and we are using HPC. So we must have a workload suitable for HPC and an infrastructure to run HPC. But you might think, oh, okay, I don't have the workload, or I might, but for sure I don't have the infrastructure. And how can I start using HPC without a big infrastructure? I don't have a data center. I don't know about you, but I have access to a few, but I don't have my own HPC. So, but we can start just playing with it. You can play with the with the HPC software on your computer, for example. And this is one of the initiatives we have. We have the Slurm charms. So you can use the charm and Juju and deploy a small HPC cluster on your machine using, for example, LXD. So we just need to create a few containers and boom, you have a small cluster. We install Slurm. So to have HPC, you must have a workload manager system. In this case, Slurm. It's basically going to control the job allocation for your workload and resource allocation for your workload. So it's a brand new world for you if you never have access to a cluster before, but you can start just playing with it. You don't have the whole infrastructure, but you can at least know how it works. Yeah, please go ahead.
Sorry again, but yeah, I'm very passionate about this topic. So like,
me too.
I think another thing that tells a little bit apart, HPC versus like could be also the architecture, right? Because on the architecture side, I don't know, I was working in HPC until I would say 2016, 2017. So things might have changed since then. But that time, you had Cray that was really going big on the number of cores per server, right? Like per node. So they were like, and a lot of, one of the things we were doing in order to improve like performances, it was actually to play around with MPI as well as OpenMP. So MPI to communicate data across nodes. So whereas OpenMP, when you are like shared memory, so you can parallelize shared memory. So when you were using Cray, we were using we were putting a lot of efforts on this hybrid core OpenMP MPI for internode and internode parallelization. One of the things I'm actually wondering is whether when it comes to HPC, there is like some sort of cloud services that, referring to the point you were making, is that if I want to play a little bit around with, HPC infrastructure, whether like the only way to have, like given the clusters, whether the only option is actually to go on-prem, so and be either like in a company that has a big cluster or like on a research institute that you have access to those clusters, or whether like some, like just random person can actually access to those infrastructure and play around with HPC architectures.
Yeah, so I think that's an interesting question. So if you actually take a look at all of the large public clouds today, they all have their own offerings around high performance compute clusters. So you have Parallel Cluster from AWS, you have, boy, I don't even remember what they actually are on the other ones, but essentially you have these cloud resources that are available. They have HPC instance types where you could get large instance types if you're looking for it. I think what Jaime was referring to as well is, sometimes it's not about being able to, like in the local exploration space, obviously if you don't have the infrastructure, it's nice to rent someone else's infrastructure, and that's kind of where the clouds are stepping in those particular spaces. But it's also kind of nice to be able to deploy it across different clouds and manage it using consistent tooling and things of that nature. So there's other interesting options that are out there. I think one of the interesting models that have come in the Slurm space recently, fairly recently actually, is this hybrid option where you you have both an on-prem, but then you have burst capacity that can actually reach out to the cloud and be able to schedule it in those particular ways. And so the introduction of this cloud computing has really kind of introduced some new economics and dynamics to actual HPC, which I think is actually very interesting, because we're starting to see, in my mind, HPC workloads, HPC software, HPC paradigm start to bridge between, I've got a data center warehouse, or 6 data centers full of machines that are actually running a bunch of cores, and starting to actually look at what can we do to rent and utilize hardware in different spaces, which enables smaller companies to start getting into play, smaller players, rather than having a large research grant or having large investment up front. You can start exploring how HPC can work into your business and into your work, into your projects of what you want to do. And I think that's actually very exciting in the world of HPC from my perspective. Is gone are the days of having tons of investment up front. There's a question over here, comment over here.
Hi, I haven't been working within HPC for 4 years, so this is very interesting to hear all of this. And 3 things have popped up to my mind, and cloud was just mentioned, and I think so. We're here kind of to talk about what's the place of Ubuntu within HPC, and how can this kind of be promoted in some way, right? And I think when it comes to cloud, the UU itself, and then the Slurm charms, for example, actually kind of brought HPC to the cloud, because now it will be possible for like a lot of people to deploy HPC anywhere, basically. And I think that's an extremely important thing that a lot of the older tools would absolutely not be able to do. But I think, I don't know, it would be interesting to hear your thoughts about, when it comes to HPC, you typically also get storage problems and scaling of storage, and performing storage, and so on. And when I was in this area, there was everything was like completely NFS focused when it came to with all the fun NFS problems that have been the same for 20 plus years. And so why not, when we're still I mean, since UU is around, and the people that are operating clusters now with UU, then of course, so they typically have all the when all the questions pop up with, okay, we have some problems with storage, with performance, with connections going down, so my job died, blah blah blah, and all that troubleshooting is on the HPC team always, right? Even if there is a storage team, it will still be by the HPC team. So why not add to like promoting Ubuntu in that area? Why not go for something like Ceph-FS and Charm Ceph instead of that really expensive? Because these people know how to operate everything in a data center anyway, right? So it makes does it make sense?
So I think that's a very interesting comment. Watch this space, where we plan on taking on the opportunity to integrate Charm Ceph into the actual Charm Slurm solution over the next few months. I think one of the interesting challenges is that when you're looking at storage in an HPC cluster, you kind of have 2 concerns. You have the need for high bandwidth, high speed storage, and you also have the need for highly scalable storage that doesn't necessarily have to be as fast, right? Depending on your workloads and different use cases are. I think Ceph-FS fits the bill for one of those, and it doesn't. That's not the performant one. Ceph is really good at scalable storage. But anyone who's actually looked at running Ceph for high performance type activities, or really high throughput, low latency type jobs, which tend to want to thrive from a storage perspective in HPC clusters, Ceph doesn't really fit the bill at this moment in time. We're interested in making that better and finding some enhancements. It's a bit tricky when you have to replicate the copy of data multiple times throughout the cluster and things of that nature. There's some inherent latency that's introduced based on certain activities that are done that way. I think that the current gold standard for a lot of high performance shared file systems is Lustre. We also don't have Lustre support within the Ubuntu archive, within Ubuntu. So we're investigating and looking into that to see kind of like what the implications are of that. I happen to have storage under me as well, so we don't know exactly what we're doing for the overall HPC storage, high performance storage offering at this point in time, but we're looking at it very closely. We know we can offer the scalable pieces, and we'll start working on that while we continue to look at what we can provide from a high performance solution. So, any thoughts from your side on that, Jaime?
Yeah, I would like to add that we are just beginning. We are just beginning this whole process. We have this road in front of us, so we have. We still need to figure out how we're gonna provide storage, for example. We still need to figure out how we're gonna provide containers, which container technologies for HPC. So I would like to highlight that we are open to suggestions. If you have some suggestions, if you want to contribute with us, we are an open group. We have this HPC team. We have weekly meetings to discuss ideas, to brainstorm in all those related topics, and think on the ways we can improve our work and provide a better product for the open source community.
Thanks. That was a valuable comment, that and new information about that self latency issue and so on. But anyway, I had one last question. You touched it briefly. The difficulties with using Ubuntu with some very expensive software that's being used typically in HPC clusters, probably Abacus and PowerFlow and whatnot.
Yep.
So earlier there was, before this this happened with CentOS and so on, those kind of vendors still said, okay, if you have a problem and you're not using RHEL, CentOS wasn't good enough.
Yep.
So if don't contact us, kind of. So now I hear here that kind of, it seems like you would still and now CentOS is still some kind of accepted solution or something. So my question is, do you see any kind of will or tendency that these companies, these big companies, in the future probably need to accept Ubuntu?
So I think that's a complicated question. It's a good question. I think the answer is yes. They will. I do predict that many of these companies will actually support Ubuntu and look for different options. I think while Red Hat is the official supported solution provider and platform for a lot of these pieces of software, we do know that there are several users that are not Red Hat based systems, but kind of are able to use the software on those types of systems because they're a Red Hat derivative, that's why I said enterprise Linux rather than specifically any vendor. I think some of the challenges recently in the downstream efforts, or what's been going on from the enterprise Linux distributions, specifically CentOS with the transition to a CentOS stream, makes that a little more challenging for users that are looking at using the CentOS variant, and obviously that sparks spinoffs of other distributions. And I'm really excited to see the spinoffs. I think that's actually really interesting and really good for the overall community to offer flavors and to offer different approaches. And I wish all of them the best of luck. I think that's made a bit more challenging with even more recent announcements from Red Hat and kind of what they're choosing to do with their licensing model, which makes it a little bit more complicated to offer the types of guarantees around security patching and other things of that nature. But I think what's interesting is that we're starting to see from other conversations with different places, like SkedMD folks, as an example, the original creators of Slurm, the current company behind Slurm, having a few conversations with them, they're seeing a lot more pressure from their customers, their clients, towards moving towards Ubuntu and supporting Ubuntu, and that will lead to other software being able to support Ubuntu with that pressure. And interestingly, it's not any of those Red Hat announcements or anything of the particular ecosystem changes that are occurring there that's pushing that pressure to actually support Ubuntu. It's actually the transition to the cloud and the dynamic resources and how well Ubuntu works on the cloud in those particular spaces. And that's the driving pressure towards more adoption of Ubuntu by HPC solutions as they look to actually expand. The risk I see there is that's kind of a new generation of HPC clusters with the cloud computing. There's still a legacy and there's still a need where there will be compute and clusters that are built that are fully in-house, and for a variety of reasons they will not go to a hybrid cloud model or to a pure cloud model or anything of that nature. And we need to make sure that we do everything we can to help kind of transition that space, but it still looks a little bit more fuzzy, and I think that the cloud's going to be the pressure that kind of like helps in that particular aspect.
Cool. Thank you.
Did you have any comments on that?
Yeah, I just have an addition, but before that, Tosta.
So, shifting the direction of the conversation a little bit, Jaime, you just spoke about the challenges on how to provide containers in HPC. We spoke a little bit about it some minutes ago. So, don't you think it is time for us, let's say the evangelists of Ubuntu in HPC world, it's time for us to provide it, like, for example, TensorFlow and PyTorch engineers provided some years ago. If you go to PyTorch website, for example, you will find many examples on how to run their software. Don't you think it is time for us to go through this path as well? Provide people with real examples and use cases on how to adopt it on their workflows and workstations?
Yes, 100%. So I think we as a community, we should start doing that. We should start promoting workshops. We start creating tutorials on how to deploy our clusters using Ubuntu. Show how easy it is to do that with the Slurm charms, for example, in different environments, either our local environments, either on cloud or on premise. And of course, show some cases where we run applications with Ubuntu, for example. We have a lot of open sources softwares that requires HPC. For example, if you talk about AI, we just have a whole panel discussing AI ideas. We have a lot of AI tools that we can just run on Ubuntu clusters, for example. If we make some cases like this, we can start the adoption of Ubuntu in large companies, and I think that's the beginning. And just a link with the previous topic, for example, we have a lot of problems to maintain clusters in our client because we have softwares like Abacus, for example, PowerFlow to run simulations, and we still need to maintain CentOS 7 images for that. Man, it's a nightmare because everything is evolving, but we still need to maintain CentOS 7. So we need to do lots of workarounds to keep things working. So, and Billy said, the clients eventually or naturally will pressure those vendors so they can move towards alternatives like Ubuntu. So, and that's the idea. We can work on both ways, either using the open source to create our cases, our showcases, and also the clients will naturally pressure those vendors to also adopt Ubuntu. I think that's the way. We can either use an open source, and also we can use the clients to pressure the vendors, because I am a client. I am a cluster administrator, but I act as a client. So at Scania, for example, you can say, hey, pressure those guys. We cannot continue deploying it on old systems. This is not, it has security issues also. We have to deal with have to do a lot of not good things to make things working. And this is dangerous. So please pressure them to to move to Ubuntu, for example. Hey, and look at that. Everybody started using Ubuntu to run AI. Look how good Ubuntu is.
Okay. I don't really have anything further to add to that. I think you've done a nice job of covering that. So, okay. Thank you all. Thank you for bearing with us.